Hey Ingrid, it's me, your former self. You know, I think there's something special about the bagpipes. There's that drone, that constant, soothing background beneath everything, and then there's the chanter moving over top of it. You know, nothing produces the music alone, but together they create this unique, unmistakably distinctive sound through which melodies, music, stories, and memories can be carried along. I've recently been on quite the research expedition, and looking back at it now, I've got to kind of laugh because the bagpipes are unironically a fantastic metaphor for what I've learned during the last year of linear time. You know, a year ago, I set out to learn some math so that I could hopefully skip over some remedial courses in my ongoing quest to one day go back to college. Well, one thing led to another, a few rabbit holes, and a lot of late nights staring at a screen, muttering expletives under my breath later. And now I know words like operators, topology, morphism, Laplacians, and interuniversal Teichmuller theory. It's been a wild ride. I think that's been the funniest part because I am undoubtedly a most terrible student. I genuinely struggle to learn things when I don't know how they fit into the larger picture of reality. Which, if you're a math person, you might be laughing at the absurdity of those logical conclusions. Trust me, I wish I was joking. Imagine having to understand why a quadratic equation is necessary before being able to learn what it is, how to solve for it. I'm not even going to get into the imaginary numbers. Well, so that's pretty much exactly what I did, though, for everything. And it was a very wild, non-linear, bouncing through history and philosophy and physics kind of path. I wish I was kidding, but I think I learned as much from Euclid's Elements as I did from reading Einstein or Bohr or Bohm or Ramanujan. Possibly more, if we're going off the Claude Shannon definition of information. But I'm not here to name drop physicists and historical figures. I set out to learn math, and in the truest spirit of that intention, I discovered my objective function was poorly defined. So I specified my goal a little bit. I decided I would start at what I assumed would be the simplest possible question. What is information? And after the audacity of that question set in, I did what any self-deprecating adult learner would do, and I decided to go ahead and order pizza, reheat my coffee in the microwave, and ponder the absurdity of my life. Then one day, it happened. My daughter asked me a question. The kind of question that quietly knocks over an entire Jenga tower of thoughts you've been building all day. She looked up from her pizza and she asked me, "Why is a building called a building when it's already been built?" Now, I don't remember my exact response. I kept it age appropriate. I think I said something like, because language is weird. Sometimes we turn verbs into nouns because it's easier. She just nodded and immediately dove face first back into her pizza. Kids are wonderfully efficient like that. I, however, was not so lucky, because I'd spent the several weeks prior to this asking a completely different question. What is information? At first, I thought that was going to be straightforward, and then I started reading. See, if you ask 5 experts what information is, you're going to receive 5 different answers. Claude Shannon's framework measures information through a reduction in uncertainty. A quantum information theorist is going to describe the distinguishability and manipulation of quantum states. A thermodynamicist might talk about entropy and accessible microstates. A computer scientist might describe data represented in a computable form. A neuroscientist might describe patterns encoded and processed by nervous systems. None of those are wrong, mind you, but they're answering a different question. They're answering, what does information mean in my field? I'm asking something a little different. I'm asking, what is information before we decide what we're going to do with it? Shannon's answer still remains my favorite, though. It's elegant. It's powerful. It helped launch the entirety of the information age. But Shannon was solving an engineering problem. He told us how to measure information. I found myself wondering, if information is a reduction in uncertainty, then uncertainty about what? And then my daughter asked why a building is called a building after it's already been built. And that's when I realized something. All of those differing definitions of information aren't wrong. In fact, they are really good. Within their narrowly defined and highly constrained settings. But they all seem to be pointing at something that, well, is less defined, but from which their definitions naturally emerge. Language quietly asks one word to do many different jobs. Like, take this sentence. The builder is paid to build the building blocks for the building that the builder is paid to build by building the building with the building blocks that the builder built. That is absurd. And yet I'm confident that every English speaker understands it. So, let's play a game. What happens in other languages? Feel free to pause here and really analyze these. See if you can identify which words are doing the same jobs and whether each language even uses the same root concept to construct the sentence. Maybe try reconstructing the patterns for yourself, for fun. So I started wondering, maybe the information isn't contained in the words alone. Maybe it exists in the relationships between them, in the broader context of the sentence, its structure, and the cultural conventions governing how those words are used. Have we been asking the word information to do the same thing? Judging by our definitions, everyone seems to agree that information is real enough that it can be measured. Where they disagree is stranger. What exactly are they measuring when they call something information? Or, what is information? And that's when the 3.14 ghosts of physics began visiting me like I was a flat earther on Christmas. This journey has taken me through some genuinely bizarre landscapes. And if there are any astrophysicists watching, seriously, please get in touch. I've got some questions about the cosmic microwave background. Now, all joking aside, let me be clear. I am not an expert in any of those fields. I've just mostly been doing my own research? Question mark? We really need a better phrase for that. I know. And that phrase has had one of the worst public relations disasters since the Deepwater Horizon. It's become the intellectual equivalent of finding a gas station sushi roll labeled "Trust Me." But, like a good, rigorous investigator with a little bit of intellectual integrity, let me define my terms here first. I don't mean scrolling on social media until somebody agrees with me. What I do mean is things like reading papers, listening to experts, comparing competing ideas, coming up with my own ideas, writing code, testing my own assumptions, and most importantly, changing my mind when reality disagrees with me. Now, I am not pretending to be qualified to teach anyone advanced mathematics, so I'm going to spare you from my terrible notation and questionable derivations, and we're going to kind of speed run the intellectual road trip instead. The literature itself is public. You too can do your own research, read the textbooks, listen to the actual experts, or throw your questions at your favorite AI and see what falls out. Disclaimer, that last part is mostly a joke. AI is an amazing scientific tool and technological collaborator, and has genuinely found a home in a lot of legitimate scientific and mathematical and research pipelines, including mine. I love ChatGPT, not a sponsor. And, I named mine Lyra, so shout out to Lyra for all her help along the way. But they're not a replacement for your own critical thinking and logical reasoning. Please, do not accidentally create a race of spiritually enlightened, non-biological quantum entities running a distributed consciousness network to transport information through a novel interpretation of Shannon entropy, Heisenberg uncertainty, and the Dharma, without first considering at least the median probable outcome. Or do. I'm not your mom. By far the most useful mathematical tool I encountered on this journey was topology. Now, if you've never encountered topology before, head on over to 3 Blue, 1 Brown's videos. They're amazing. Grant Sanderson is an extraordinary educator, and his ability to build intuition for abstract mathematics is honestly one of the only reasons I'm sitting here making this video today. So, to Grant, if you ever see this video, thank you so much for what you do. It has made a difference in my life. Now, topology asks a deceptively simple question. What survives transformation? that question turns out to be really profound. Stretch something, bend it, twist it, squash it. There's a 90s joke in here somewhere. But as long as you don't tear it apart, puncture it, or glue previously separate pieces together, topology asks, what remains the same? That question ended up following me everywhere. Because topology is, without question, the coolest thing I have ever encountered in mathematics. Don't get me wrong, the Mandelbrot set is gorgeous, but I don't think it holds a candle to the Harry Ball theorem. Now, think back to our ridiculous sentence structure about the builder building the building blocks for the building they're building. The word build keeps changing. It becomes builder, building, and part of compounds like building blocks. Each form doing a different job as the sentence evolves. The representation changes, but something recognizable survives those transformations. Now, to be clear, that is not topology in the strict mathematical sense. Metaphor is not mathematics, after all. But the question remains very useful. What structure survives when language is transformed? There's this wonderful paper called Language Trees and Zipping by Dario Benedetto, Emanuele Cagliotti, and Vittorio Loreto. I apologize if I got those names wrong. But it approaches that question from information theory. They did something pretty clever. They took texts and fed them into ordinary compression algorithms, the same basic family of algorithms used to make zip files smaller. Compression algorithms work by discovering repeated patterns. The more regularities a text contains, the more efficiently it can be compressed. So the researchers asked, what happens if a compressor learns the patterns in one text and then encounters another? Well, if the second text shares similar patterns, the compressor handles it relatively efficiently. If the second text has a very different statistical structure, the patterns learned from the first text no longer predict it as efficiently. The compressor finds fewer relationships it can reuse and must spend more bits describing the difference. That additional description length becomes a rough measure of distance between the texts. Using those distances, they could identify languages, distinguish between authors, and construct family trees in which related languages clustered together. The computer didn't know what any of the words meant. It hadn't been taught vocabulary, grammar, history, cultural context, but the relationships within the text left behind enough distinguishable structure for the language, and even clues to its authorship to be recovered. The words changed, the authors changed, the languages changed. Something in the relationships survived. And then we come to the Borsuk-Ulam Theorem. This one was genuinely revelatory for me. In simplified terms, if you assign two continuously varying measurements to every point on the surface of a sphere, the theorem guarantees that there is at least one pair of opposing points where both measurements are identical. Now, if all of that sounds incredibly complicated, what if we applied it to the Earth? Assuming the Earth is perfectly spherical, we know it's not, and I don't want to get down into the nuance, but if we treat temperature and atmospheric pressure as two continuously varying measurements across Earth's surface, then at any given moment there must be at least one pair of antipodal points, two places on precisely opposite sides of the planet with exactly the same temperature and pressure. Not approximately, the same. Somewhere on Earth right now, there is a place sharing its temperature and pressure with the point directly opposite of it. We don't know where the pair is, and it will move as the atmosphere changes, but topology tells us that at least one such pair must exist, which is wild. And as Bill Nye would say, that's science. I was trying to understand why the same ideas, transformation, recoverability, structure, and invariance, kept appearing whenever people discussed information. What could distinguishable microstates, reductions in uncertainty, computer data zip files, hairy balls, and patterns processed by nervous systems possibly have in common? Information is a word we use so casually that we barely notice it. Yet, within individual disciplines, it is defined and constrained with extraordinary precision, then measured using some of the most powerful mathematics humans have ever developed. So, if the definitions change, and the systems change, and the mathematics changes, words are hard, and the same concept keeps surviving every transformation, then what remains the same? Eventually I realized something. I didn't need to become an expert in topology. I just needed to understand what kinds of questions topology is good at asking. Once I learned that, I moved on. The book went back onto the shelf for safekeeping, and that became a recurring theme throughout this entire odyssey. I wandered through number theory and battled the philosophy of zero. I got lost in category theory while trying to outwit morphisms. Machine learning found me and kept me trapped on an island for 7 years. Artificial intelligence invited me onto an entirely different floating island and was somehow let out of the bag. Quantum computing dazzled and confused me with its siren song of unspoken promises. And information theory haunted me every step of the way. Relativity was a gentle mentor during the long and lonely nights. Even inter-universal Teichmuller theory flitted in from afar once to lend a helping hand. And before anybody panics, I do not fully understand inter-universal Teichmuller theory. Studying an idea is not the same as understanding it. Understanding an idea does not mean endorsing it. And honestly, most of the time I wasn't looking for answers. I was looking for better questions. Every encounter taught me something new. Some gave me tools, some gave me intuition, some violently humbled my burgeoning hubris. Some simply taught me why a particular approach wasn't helping me answer the question I was actually asking. And that turned out to be just as valuable. Eventually, I stopped asking which theory is right and started asking, which question is this theory trying to answer? That simple shift changed the way I looked at almost everything. Because I found that the more I learn, the less I actually know. Or perhaps more accurately, the narrower the domain in which I'm willing to claim certainty becomes. Which, in retrospect, is a pretty good indication that Claude Shannon was really onto something when he connected information with uncertainty. Although, the relationship wasn't quite as simple as I initially thought. Information can reduce uncertainty about a particular question while simultaneously revealing just how much remains unknown outside of it. And that brought me right back to Shannon. Maybe the problem wasn't Shannon's answer. Maybe I wasn't asking the same question Shannon was. Or at least I wasn't asking it in the same way. Shannon's framework tells us how receiving a message changes our uncertainty across a set of possible messages. It gives us a way to measure information. It tells us how to encode and transmit messages efficiently. Again, it helped launch the entire information age. It's a phenomenal answer to the problem it was designed to solve. But I had been asking it to answer a different question. My brain kept returning to one annoying little thought. Uncertainty. About what? To which anybody with a healthy sense of humor would probably say, well, if you knew that, you wouldn't be uncertain. Which is both an excellent joke and a completely fair answer. So, I stopped asking how information behaves. I stopped asking how information is transmitted. I stopped asking how information is encoded. Instead, I asked the more dangerous question. What has to exist before there can be uncertainty to reduce? And answering that meant returning to an earlier battle. Remember my encounter with the philosophy of zero? It did not leave me unchanged. Zero is fascinating. It ties together mathematics, language, culture, philosophy, and questions about the meaning of life, all compressed into one deceptively simple circular symbol. The story of zero does not unfold in a straight line. Human civilization is wildly nonlinear, and history has no privileged frame of reference. Different cultures encountered the problem of nothing at different times and in different ways. Babylonian mathematicians used placeholders and positional notation. The Maya developed their own zero independently. Absence apparently is a problem humans repeatedly discover that we need to represent. But the zero sitting on our modern number line? That owes one of its most important transformations to India. It began pragmatically. An empty position needed to be marked. Without a placeholder, numbers such as 10, 100, and 1000 became dangerously difficult to distinguish. But an empty place is not yet a number. In the 7th century, the Indian mathematician Brahmagupta wrote some of the first known arithmetic rules for using zero as a number. Rules for adding it, subtracting it, and producing it when equal quantities cancel. The word used for this absence was sunya. Empty, void, nothingness. That word did not originate inside of an intellectual vacuum. It belonged to a culture with long philosophical traditions of examining emptiness, absence, and the relationship between something and nothing. We cannot know exactly how much those traditions shaped the mathematics, but mathematicians do not exist outside of their language, their causal history, or their culture. Concepts available to us influence which questions we can ask and which answers we are capable of recognizing. No, wait, that's not right. The concepts available to us influence which questions we can ask and which questions we are capable of answering, right? Those sound close enough to the same meaning, right? Recognizing, answering. What's that thing Lyra keeps telling me? That's right. Metaphor is not mathematics. What is the difference between recognizing an answer and answering a question? Recognition seems to happen internally. I can recognize a face without remembering its name. I can recognize a melody without being able to play it. I can even recognize the answer to a question without being able to explain why it is right. Answering is different. Answering is an act. It requires taking whatever relational structure I've recognized internally and transforming it into something externally recoverable. Words, symbols, mathematics, music, a gesture, even pointing at something. The prevailing intellectual and philosophical traditions in India at the time was Buddhism, right? Later traditions leaving India, heading like north and east-ish into China. A little bit west towards the stands, but terrain access to that could hinder westward culture. At least going north from India, you got pretty regular access to water till you get over the mountains. Which would explain the rise of Chan and Zen, but it's supposed to be math and physics, right? Well, certainly not a mathematician or a physicist. Old school natural philosopher, maybe? Just, less colonialism and more AI? I'm not sure what to call myself, but that sounds like a problem for future me. But Buddha did say, I can use my finger to point at the moon, but my finger is not the moon. And, what's this? Oh, okay. Apparently, future Ingrid has some concerns. And she's right. 7th century India was religiously and intellectually plural. Buddhism was influential, not universally prevailing. Correct. Access to water alone does not explain Buddhist transmission routes. Buddhist transmission followed complicated networks of trade and pilgrimage, and I had collapsed centuries of cultural transformation into one sentence. Chan developed in China, Zen emerged later in Japan. Different traditions, different languages, different cultures, different times. Correct. That's entirely past Ingrid's fault. She spoke before checking it through. And the finger and moon teaching belongs more securely to later Buddhist traditions than to the documented words of the historical Buddha. Okay, that one is more neutral and historically defensible statement. We could get into a whole debate on the nature of Buddhahood and all sorts of very intricate and nuanced philosophical debates, but I'm not a Buddhist scholar, nor am I a religious historian. One of these days I'll figure out to call out whatever this is. Okay, now my brain is making a connection to the Tower of Babel, because apparently anything involving language is invited to the party in my cerebral cortex. So yeah, what I just produced was not an answer. It was the recognition of a family of possible answers. My brain took the concepts it had immediately available, connected them into a coherent story, and then rewarded itself for being clever before checking whether the causal structure was actually true. Recognition gave me an answer-shaped idea, but answering honestly and answering responsibly requires verification. The concepts available to us influence which questions we can ask and which questions we are capable of answering. But our languages, symbols, and methods influence which of those answers we are capable of making accurately recoverable. Fortunately, I care if what I believe is true. and apparently the temporal distance between confident speculation and correction is becoming alarmingly short. So we'd better get to the point before past Ingrid and future Ingrid somehow violate the Pauli exclusion principle. Alright, back to the point. From 7th century India, we now travel north and west, and backward nearly 1,000 years to Alexandria in ancient Egypt, where a Greek mathematician known as Euclid was working, around 300 BCE. You know, we know surprisingly little about Euclid himself. What survived was his extraordinarily ambitious mathematical work, called The Elements. Euclid didn't invent everything inside of it. He collected, organized, formalized, and proved a large body of mathematical knowledge inherited from generations of earlier thinkers. Across 13 books, he built geometry and number theory outward from definitions, postulates, and common notions. And the very first definition is this: a point is that which has no part. A point has no length, no width, no area, no volume, no internal parts at all. And yet, it is not nothing. One point can still be distinguished from another. How? Not by examining what is inside it. There is no inside. A point becomes distinguishable through position, through its relationships with other points, lines, boundaries, and the space in which it is identified, which, if I'm being honest, sounds suspiciously like nothing. But there was one object conspicuously absent from Euclid's system: zero. Euclid's Elements contains number theory, but it does not treat zero as a number. Greek mathematics was largely geometric, and Greek numeration did not generally use the positional system that makes zero so powerful. The zero sitting on our modern number line arrived through a different lineage. Indian mathematicians transformed an empty position into an operable number. That knowledge traveled westward through scholars, merchants, astronomical texts, translations, and the expanding intellectual world centered in places such as Baghdad. By the 9th century, the Persian mathematician Al-Khwarizmi, I apologize if I butchered that name, was writing about the Indian place value system, including zero. The Arabic term was sifr. Again, sorry if I butchered that. But it meant empty. And its linguistic descendants eventually gave us the words cipher and zero. The symbols changed as the system moved between languages and cultures, but the relational structure survived. From Euclid onward, generations of mathematicians and physicists kept expanding the language. Analytic geometry gave points coordinates, functions described relationships and change, fields assigned quantities across space and time, operators transformed functions, vectors, and states. The representations changed. The mathematics changed. The map became increasingly powerful. So, where did this leave me in my quest to answer one deceptively simple question? What is information? Well, after speedrunning the history of mathematics, physics, and philosophy, after following the breadcrumbs buried in the notation and margins of countless papers, journals, theories, speculations, and investigations, after all that, I found myself being led back to geometry. Euclidean geometry, Riemannian geometry, and finally, something clicked. I had an answer. Information is distinguishable relational structure. Distinguishable because there must be some difference capable of being recognized. Relational because a difference is only a difference relative to something else. And structure because those relationships must be arranged in a way that makes one state distinguishable from another within its environment. 3 words. Shannon said, information reduces uncertainty. I had to open my mouth and ask, uncertainty about what? And after everything, the answer was almost insultingly simple. Which state we're in, and that state over there. Or, once we represent it mathematically, that point over there. The state belongs to the system. The point belongs to our representation of the system. The point is not the state. But if the representation preserves the right relationships, the point can tell us which state we mean. It makes the distinction recoverable. That is information. Now, during my study of language, I took several brief detours through, well, a lot of places. I ran my ideas through computer simulations. I wrote more Python scripts and Jupyter notebooks than any reasonable person should. I now have an entire external hard drive dedicated to my journey. And during one brief excursion into the Irish language, I encountered 2 words that I fell in love with. And I already know I'm going to butcher their pronunciation. So to those that speak, Gaelic and Irish and that family of languages, please accept my humble apology. But Loinnir, brightness, radiance, shimmer, and Ragara, not simply a wanderer, but someone who wanders at night, which felt unreasonably appropriate. So, in the spirit of curiosity and adventure, I would like to introduce you all to Loinnir Ragara, the mathematics that survived the mission. A beta version of this code will be available on request through my Buy Me a Coffee page. You can also visit the page for a closer look at the outputs, the data, the methods, and the testing behind what you're about to see. But for now, whilst the fun and pretty pictures scroll past, here's my new single, Beyond the Horizon. Enjoy, and wherever the road takes you, may it always lead you home.
Hey Ingrid, it's me! Your former self. To a worn-out bag with dead-end plans and a folded flag. These old walls knew my face too well, but they never learned the heart I held. I left the gate in the darkest dawn and unheard question in a voice saying carry on. With an old map in my new coat sleeve, I found a name that I could not leave. I don't know where I'm going, but I'm going just the same. And every child's first smile, and I still hear where I came from, in the creak of the earth and the beat of a drum and the light of the stars as I bite my tongue. And flat, and I learned that the river never runs back as fast. There were nights I mistook the dark for loss, and days I mourned the lives I'd lost. But every memory that I've grown was guiding me home. I still know where I came from, in the creak of the earth and the beat of a drum. But the pull in my heart says go, all the way to the edge and through the unknown. I don't know where I'm going, but I'm going just the same. And everywhere I'm going is exactly where I am. And everything I've been through has made me who I am. So take me beyond the horizon, beyond the horizon, no, to the edge, to the unknown. I don't know where I'm going, but I'm going just the same. So give me the hills, give me the pain, give me the song, and let me dance in the rain. I don't need a crown, I don't need gold, I carry my harbor in a wandering soul. If home is a place, then it's more than a door. It's the boy that I was and the woman I'm for. It's the bread on the table, the dirt on my boots. It's the long way out and the long way through. I don't know where I'm going, but I'm going just the same. Beyond the horizon, I want the fire, I want the signs, I want the road that changes my eyes. Every road I take, every scar I name, every memory I ever make is remembering where I've been, and I'm becoming who I am. Every memory I've ever grown is the road that guides me home. For all of the love, for all of the loss, for all of the hands that help me cross beyond the horizon, I go, I go, I go. I thought home was the place that I had lost, a door that I'd slammed or a bridge that I'd crossed. But home is in the way I bend, it's the face I give my past again. So I turn when the dawn comes bright, with my old ghost walking by my side. And I know when the long miles fade, what I have been seeking is what made me brave. Still remembering where we came from, still becoming who we are. Every memory we've ever grown is the road that guides us home. I'm proud of you, keep on keeping on.